Okay, let's take some look at how we can apply this. So, in a simplified version, we're told lambda is 3.5. So that's our rate. So that could be the rate of cars hitting lampposts in an hour. Could be the number of fish caught in a day. It could be the amount of corn grown in a crop of a metre square of farmer's field. It could be the number of red blood cells you expect to find in a syringe taken of blood, as long as it is a rate of some description, an average rate. We're asked here to find the probability that x equals 2. So let's write down our Poisson distribution. So x, the Poisson, so this is our normal setup, and in this scenario, x is modelled by the Poisson with a lambda of 3.5, and the probability that x is any number, if you remember, is e to minus lambda, lambda to the x over x factorial. So in this scenario, in the chance that x equals 2, so for example, that there are 2 ears of corn in this 1 metre squared of field, is going to be e to minus lambda is 3.5 times 3.5 to the power of 2 over 2 factorial. And you can work that out for yourself. And you should find that comes to 0.18495, so round that to 0.1850. Let's look at this in a practical context. So back to our glorious, happy, fun, exciting idea of the Zika virus. Sorry it's such a depressing example today. So in a hospital in Rio, they average 2.5 new cases per day. So per day tells you it's a rate, it's an average. So our lambda, before I even read anything else, I know that x is going to be distributed by the Poisson with a lambda of 2.5. And we have to find that on a randomly chosen day, there are fewer than 3 cases. Just going to double check it, fewer than 3, so number line 0, 1, 2, 3, 4. Fewer than 3, so can't include 3, must include 2. So fewer than 3 is chance getting 0, 1 or 2 cases. Okay, and I'll write down at the start the probability of of Poisson times lambda to the x over x factorial. So I'm giving all the information at the start. Then let's construct the probability distribution for this scenario. So x and the chance that x equals x, and we want to go to find 0, 1 and 2. So to start us off, if case of 0, well, essentially it boils just down to e to the minus lambda. So that's going to be e to negative 2.5. And x is 1. Remember, now people tend to confuse and mix up where the 2.5 and the 1 go in this scenario. Just try and stick very carefully that lambda is 2.5. You're always referring back to what you're doing, and I'm being very careful not to make the mistake right now, because that would be embarrassing. Lambda is 2.5 times 2.5. X is going to be 2 over 2 factorial. And use your calculator and practice using that E button to calculate those 3 values. You should have found this to be 0.08208, etc. This to be 0.20521, blah blah, and 0.2565, etc. My tip is, if you're actually working this out, you do not want to calculate all 3 individually and add them up. What you want to do is trying to do all of it into one calculation, because every time you just cut off, truncate those numbers, you're missing out on detail, which may put your answer off a little bit. So the probability that x is less than 3 is going to add up all these probabilities, and that comes to 0.5438, or a 54.38% chance that there are fewer than 3 cases on a given day. And of course, if you are the manager of the hospital or the senior consultant, you may wish to consider how you're going to staff and resource a hospital given the chance of having less than 3 is about 50-50, 50%. The last thing to look at is the conditions for the Poisson distribution. Okay, it has the following conditions. First of all, they're below that. First of all, that events are random and independent. So in this scenario, we're kind of assuming that the chance of catching the virus doesn't depend on anyone else having it, that there's a constant rate of the virus being caught. Okay, we're going to assume that there are going to be natural numbers, i.e. you can't get 2 1/4 cases or 2 6/8 cases. You can't get 3.5 cases. They're whole numbers. You can get 1, 2, 3 or 4 cases, etc. Of course, the average might be a decimal, because averages aren't always nice whole numbers. Okay, and events happen at a constant rate. So this rate that you calculated, that the hospital calculated, stays constant throughout. So this starts to change and makes the whole thing pointless. Okay, the big difference between Poisson and binomial is there's no fixed number of trials. In the binomial, you had to know there were 10 trials or 6 trials. You rolled the dice 20 times. Here, this is potentially infinite. Yeah, in the case of Rio de Janeiro, you could theoretically have the whole city catch the virus in the same day and report it on the same day. And the Poisson can deal with that.